Sorry for that interruption with the last video session, I will continue up with the remaining work. We have left on how the W script file can be manipulated, and it is being used for to bundle up whatever our uh, new in our module. If we don't mention, it won't be available at the runtime. When we look at the examples is where you can put actually uh, it's the example simulation that you can create for this particular module. When we say for this particular module, that means uh, for a AODV trust module, we can create our own simulation to demonstrate how the AODV trust module will be used while you run a particular ns3 module. If I say it again, like that is actually when we look at the AODV itself, or else I'll take another protocol called DSDV. DSDV has the similar structure which the ns3 provide us by default. When you go to the examples folder, you can see there's a file called dsdv manage. This file is actually to simulate how the DSDV routing protocol will be used. Once, just to make sure, just open it up and see. They have created an example. Actually, this example can be ran and see the output is actually it's a similar simulation. All right. So the example file is basically to provide an generic form of your simulation for the other users who will be looking at your module. And you have the helper. Helper folder is for the helper classes, and the model is okay. I'll little bit explain about the helper class. Helper folder is like if you have a scenario to be uh, use any particular ns3 core level functions, we don't we are not actually allowed to directly call upon those methods. Instead, we have to use an particular helper inside your module, which will actually delegate all your requests to the necessary core level functionalities. If you open up the ns3 in this case, this is the helper class for this particular module, which means for the uh, AODV trust module, we have one helper class called AODV dash trust dash helper. When you open up the header file, you can see we have few methods actually. This particular helper, this the class is being extended from the IPv4. IPv4 routing helper is like an abstract level or a higher level class which ns3 has provided, which actually being used for all of the IPv4 routing helpers. Being that said, like um, it means the AODV routing protocol itself is an IPv4 routing protocol. Therefore, when we use a helper class for our AODV purposes, we need to extend from the IPv4 routing helpers, because there are some IPv4 specific functionalities which will be extended to our particular implementation class. I will go through in detail about what are these methods and all once we come to the routing protocol session. Just for now, just for the moment, just think this folder has the helper classes. or else you could map it like in your mind. You can think like a delegator classes which will be used to connect between your module and the ns3 core modules. Uh, what I meant by ns3 core modules are, you can see, actually you can see it by yourself, like there's a module called core, and there's another module, well, a lot of modules like internet, mesh, mobility. Those are like the features that you can enable for your simulation, but uh, it's like plug and play. You don't need to use all the modules that are available inside the ns3. It, depending on your requirement, you can use whatever the necessary features. Most of the time we'll be using the internet and the mobility in our case, because we are trying to simulate a mobile network. So we will be using the mobility, and also internet is for the ipv4 uh, stuff related like that. So internet will be used, and there are a lot of other modules being using also. And so let's move back to our AODV routing and trust protocol module, trust module. And so I explained about the example folder, then help folder. Then this is the most important folder for any module. When you take application for module, there'll be folder called model. Uh, the model is like the source. So, the all the source files with regards to this module will be placed upon inside this module, inside this folder. In our case, we had AODV trust module, and we also have the folder called model. This model has all the source files. So we have all the source files inside this model folder, and we can have a quick look at it. And then we can write test cases for our module. That means for AODV trust, or whatever the classes or the logics what we have written inside this model can be tested. I haven't still used test cases for so far, so I have no experience on how to do that. But when you look at the other existing modules, like the application, you had UDP client server test, and when we click on the CSMA, another routing protocol, it will have their own test cases. See how the test, it's a Python file actually, so through my text editor. Okay, so basically, for the moment, we can skip on what how to write a test case, because we are still in the development phase. I think I have covered almost all the folders and how the structure within a module inside ns3. Uh, well, now I will go through the model folder inside our AODV trust module. We have a lot of files that we have already created, and the default files which ship with the default AODV protocol. So most of these files which are starting with AODV hyphen are the files that came with the default AODV routing protocol. When you open up the default AODV routing protocol and go to model folder, you can see these are the default files, or else the existing files that is in the AODV routing protocol module. So I took a copy, as I said, from the AODV to my own module called AODV Trust, and therefore inside the module I copied the particular files also. Otherwise, I won't be able. I have to refer to this particular X default AODV routing protocol, which will be not. Uh, which will make my developments a mess. So I didn't want to do that. I took a copy of the same files over here and modified accordingly. The first, uh, before I start off with the implementations, I will start off with an example file. When you go to the examples, there's something called AODV trust. Say this is an example file. That means that this is a simulation which was inside the AODV example folder, because this one I even the example I copied and pasted in my module and change a little bit depending on my requirement. So let's walk through this AODV trust CC, which is an example simulation. The simulation is a very simple one. It says it will be, there will be four network nodes, and we are going to send a ping from the first node to the last node. So that is our simulation network environment, and we have configured some of the uh, things like the number of network nodes, the distance between node, simulation time, how long you need to run the simulation. So those things can be configured with inside this example constructor. We have set actually the size to be 3. That means we will have only 3 nodes, and step is the number of meters that has to be between uh, for any particular two network nodes. There will be 20-meter difference within two network nodes, and we will be having 3 network nodes. This simulation will run up to 10 seconds, and the print routes will be just some flags. When we run the simulation, some of these logs will be printed. So the configuration is actually setting up some values to the variables, assigning. Then this has the run method. This is where the simulation will going to start. So this example will be start off with this run method. First it will go and create the network nodes, then the devices. Then once devices has been created, we will going to install the internet stack on top of those devices, and then we are going to install the application. These are like the ISO network layer, ISO SI model. Like we have the physical devices, then we have the hardware levels interactions, then we have the high level applications. So we have to create our simulation accordingly. Well, then I have just only put a simple printout statement just to see how long this simulation will run. So this is the total time which shows how many seconds this, how the time period length. And these three lines are a little bit different than what we have seen already, because this is something called uh, a separate module within the ns3 software, but we call this as a simulator engine. If I elaborate it well, like there is a particular module called ns3 engine, which actually um, schedules the events that we put to simulate. Uh, Further, if I explain more, the ns3 software, or the in the runtime, ns3 software acts like a event based software. I mean, for in order to happen a single print statement or anything, it has to be sent to the ns3 co executor as an event. That means even for to run this simulation, that means the file that I have already opened, it's a simulation, right? So we need to run the simulation. So we are telling, okay, we have the simulation event. So put it into your event queue and run it exactly at the times that we have defined. So in this case, we are saying simulator, we have to stop the simulation by this time. So you can start it right now. And once the simulation has stopped, you can stop, destroy that event. We don't need it anymore. So it will clean up the memory as well. Okay, so we'll go and see how we have created. The first task what we have done was creating our network nodes. This is a print statement. You don't need to worry about it. Actually, this print statement, what are which we have put it as std out or standard command line print. The ones that I have wrote. So in the ns3 code, we don't have any sort of print. Instead, we will have something called logs, logger.print, logger.info, logger.error, because ns3 has used logging mechanism. So I haven't used it because it is like bit difficult for me to keep up on that. So I simply use this standard printouts. So there's a variable called the node container, and we have created passing how many nodes we will be expecting this in this network simulation. So we have passed it, and it will create and return us the wrapper class called network container. So the container is actually holding all the network nodes what we have. And so we iterate through that uh, network nodes, not the nodes, actually this is the container, network node container. And we get one one at a time, and put it to some other container names. Then we install the mobility helper, which will be used to define the positions and how the mobility has to be work. In this case, constant position model at the start, then it'll be moving this simulation. So creating nodes doesn't had much to do except that it creates the network nodes and stored in the network not node container. Then we go to the create devices. Create devices has a lot to do with the Wi-Fi configuration. We have defined and set a Wi-Fi helper, and basically at the end we have actually installed this Wi-Fi to our nodes. This is the node that we have created earlier. That means the node container. We pass this node container and ask the Wi-Fi helper to install this Wi-Fi device for each of the nodes in which stored inside this node container. So with this install method will do the work for us and return the devices. So we have created the Wi-Fi devices and install for each of those nodes. Then we will do the install internet application stack, internet stack actually. Internet stack is where we define the IP addresses and all. We use the IPv4 address helper to make it work, and we have passed again the devices in the sense the ones we have uh, installed the Wi-Fi enabled adapters and all. So it will return the interfaces, and then the applications. For our instance, we have to use the ping helper, but this if we use the ping helper, there won't be any data packets because